Salam sejahtera keluarga Malaysia. Selamat datang pada hari ini bersempena Minggu Sains Negara Keluarga Malaysia 2022 sertai kami dalam Innovation, Robotics and Coding Competition IRCC 2022. Objektif IRCC ialah memupuk minat dalam pendidikan STEM dan robotik coding serta wujudkan peluang kepada pelajar untuk menyertai pertandingan inovasi, robotik dan coding dengan
Good morning,
menggunakan
please on mic.
Oh, so sorry. Okay. Objektif IRCC ialah memupuk minat dalam pendidikan STEM dan robotik coding serta mewujudkan peluang kepada pelajar untuk menyertai pertandingan inovasi, robotik dan coding dengan menggunakan robot digital. Terima kasih kepada pihak Kementerian Sains, Teknologi dan Inovasi MIMOS MRANTI memberi sokongan kepada pertandingan IRCC. Terima kasih. Terima kasih kepada pihak Kementerian Pendidikan Malaysia, semua Jabatan Pendidikan Negeri, cikgu-cikgu kerana memberi pengesahan dan sokongan IRCC sejak tahun 2020. Terima kasih. Ya, kami berbesar hati menjemput dan berterima kasih kepada Mr. Vincent dari Vincenzo Labs Sarawak bersama dengan kami hari ini. Explore STEM and Coding with Rero Micro dan Mr. Vincent dipersilakan.
Terima kasih. Selamat pagi semua. Nama saya Vincent. So berbesar hati dengan organizer kerana menjemput saya untuk memberi taklimat workshop dengan menggunakan Rero Micro. Rero Micro adalah saya share saya punya Windows. So yang ini adalah robot Rero Micro. So for those of you, if you have it, then you can take a look. Maybe I can just share. This is the Rero Micro video. I'll just use this one. I'm going to play this video. So to explain to you what actually is
Show me where to go.
What you How about now? Okay. Now can. Oh my goodness, so sorry. I did not know that you cannot hear me at all. Okay, so tak apa. So biar saya ulang sekali lagi. Okay, so tadi saya sudah tunjukkan itu video lah, video boleh tengok dalam YouTube lah. You boleh search youtube.com/rero kit. Okay, dalam itu ada banyak produk yang dikeluarkan daripada Cytron Technology yang berasal di Pulau Penang. Okay, so you boleh dapat tengok yang Rero Micro ini ialah dia sebuah robot, okay, mobile cars, robot cars yang kita boleh menggunakan atau cara untuk program dia seperti like NeoPixel, seperti movement, and then also the sensor yang dapat ikut line dengan obstacle detection. So all of this we can actually learn, use the educational robot kits ini untuk belajar bagaimana kita dapat menggunakannya untuk memberi exposures to our students that they can learn on how to do the epidemiologies by gunakan sensor-sensor yang terdapat dalam robot itu. Kita boleh programnya untuk mengikut track, mengikut black line, okay, ataupun the white line. Okay, the white line basically to avoid the white. Okay, so I will try to cover as much as possible dalam workshop ini untuk memberi peluang juga kepada guru-guru yang baru mengetahui tentang robot ini. Saya tahu ramai cikgu-cikgu sudah pun know this robotic kits, but then for the benefits of those that who do not know, I will try to do as much as possible and will try to cover it from the daily basis to I will try to cover the life following, okay, the latest steps. Okay, all these are PDF. You can be able to download it from the resource folders, or you can also get it from maybe listening. Okay, so all these are available online. You can download it. This is all the bullets which is available for you to download. Okay, and also come with the kits as well, and together with the tracks. And so okay, so basic housekeeping of the robot is basically you need to keep your battery charged, right? That is how you extend the lifespan of your battery. Don't let it like until 0%, but maintain it at least 75% at all time. If you plan to do not use it for quite a long time, then fully charge it and maintain it at 75% or minimum 50%, okay? All right, so basically what you can do is you can charge by using the telephone chargers, okay, the cable. You can use like micro USB cable, which is you can get it anywhere, Android handphone. Okay, you should be able to come with it, okay. You boleh guna apa-apa charger saja, ataupun you boleh pakai laptop pun boleh. Kalau you pakai handphone charger mungkin lebih cepat lah. Alright, atau you pun ada itu lithium punya charger. You can use the lithium charger, keluarkan bateri ini, pakai lithium charger untuk charge this lithium battery. What is 18650? Okay. Alright. So that is the basic housekeeping on the robots. So here are the Mac code editor page. Okay. So we can go to this Mac code editor page by typing maccode.microbit.org. Okay. So you all can be able to access cross-platform, meaning walaupun you guna Windows, okay, ataupun you pakai Mac ke, ataupun you pakai Raspberry Pi pun boleh pakai guna browser OS tu untuk membelajar macam mana kita boleh pakai Mac code editor page untuk learn the broad programming. Okay, so we can just go to this website and then we click to the new project. Okay, let's name our new project lesson 1. Yeah. Okay, in all of the programming, right, they are always start with on start, okay? And here, there are two blocks you can see when you create new project. One is on start, one is forever. Apa maksud on start dengan forever? Okay. From what the name suggests, on start ialah bila you power on the microbit. That is the line of code that is your first run. Okay. Itu adalah atau cara yang pertama akan dilaksanakan oleh microcontroller tersebut. Okay. Okay. So, yang ini ialah laci-laci, we call it category drawers, that you can get all the blocks, okay, that you want, or you can simply type it out by using the search. Okay, so kalau cikgu-cikgu tak ada hard way untuk memberi pembelajaran, tak apa, kita dapat menggunakan simulator sini. Okay, here is the simulations where we can use it to do pembelajaran. Okay. So let's try to go to the basics. Okay, basic here, the source number and short string is the difference is like this is using to show the numbers, and this you can do text. All right. So let's try to do the short numbers. Okay, we can type like 1. Okay, 2. Okay, and also we can do something like this one. And we let it wait for 1 second. Then we can do 3. Okay, and we can also use loops. Okay, loops here we got the index, right? Okay, the loops here is also like repeat, okay, dia akan repeat, tapi dia dapat tahu dia repeat berapa kali. Okay, so here, for example, here it start from 0. We can also use a short number. Okay, so we can actually use the mathematics here. Okay, here is the mathematic operators. Okay, we can choose plus. So here, since we already passed 3 here already, right? So this one should be, we want to show number 4, but it begins with 0. So we can use 4 plus. We can drag the index, put it here, and we just duplicate this one, this one. Okay, so now we can see from the simulator here, we run it. Okay, so 3, 4, 5, 6, 7, okay, 8. Okay, so this is on start. Once it's finished right there, right, it just ends here. All right. So how about forever? Forever is something that it will repeat forever. Okay. For example, if I put something like, let's see, a flashing heart maybe. Okay, so now we try again with the simulator. Okay, so after this one, the code ends, it will go to forever, then it will become flashing heart. Okay, so far, okay, everyone can follow, right? All good, right? So I assume if you have question, you can always raise out your hand. Then we'll come back to you on that. All right. So now the JavaScript and Python. Okay, what are these? Okay, this is very interesting. The engineers behind, the software engineers or the application engineers, they have very cleverly translate this to board programming and the text programming like Python and JavaScript. So you can actually translate it to JavaScript if you want to learn. Okay, learn this text programming. All right, so you can learn by just select the programming language that you want to learn. All right. Okay, so these are all test packs. But if you want to go back to the board, just simply click on it. Okay, so it's very, very useful. Okay, so a bit of history about microbit is this microbit actually is introduced by UK to the K-12 students, and they have been given out a few millions of units to their students. All right, and just recently we have introduced this to the our school syllabus, and so this microbit it have 21 pins. Okay, and we also have something similar like this one. Maybe I should let me try to change my setting. I don't know how to change the. Okay, how do I turn off this thing? Okay, so these are the 256 neopixel. Okay, so last time because V1 can only handle 90 milliamps, we can like support to the voltage can support to like 256 neopixel, and it can create a lot of animation by using that neopixel, that many neopixel. But with microbit, we also can have fun with the neopixel because it has 7 neopixel. So you can basically use it to program rainbow, right? Rainbow color. So how do we do that? It's very easy. So what we need to do is we just go to the extensions and we install the NeoPixel extensions. So dalam sini you will see the NeoPixel extension kan? Okay, we can go and click on it. Okay, so we can set street. Okay, let me do away with this. Okay, so this one, the street actually is a variables that we use to define pin 1 F7 LED. So on the PCB board here, you can see there is a supreme P1 here, indicate they are using P1, the pin 1, to power and program this 7 LED, RGB LED. Okay, so once you do that, we can try to do something like show color red. Okay, so you can see the simulator, it shows color red, all color red, right? And then rainbow color. Okay, so let's try something like this. Okay, so you can see the difference. Okay, so you can see the difference, right? So it will show these two colors. Okay, now let's apply what we have learned with the in-text. Tadi kita sudah belajar in-text kan? So kita juga boleh program the microbit untuk power up the NeoPixel 1 second at a time. How do we do that? By using the index. Okay, let's go to the loops index. Okay, so since it's begin with 0, we want to power up all 7 LEDs. So we need to repeat 7 times. So it's 0 to 6. Then we can use the NeoPixel and begin more. Then we can set to pixel color at 0 to red. Then we can drag the index for the 0 and put go basic. You can put the 1 second. Okay, so every second you will turn on 1 LED. And at the end of it, if I want to turn it off, what should I do? I can just simply show color black. Black means other color, that means turn off. Okay, so let's try. If you have a robot with you, you can always pair your device. Okay, click pair your device with your robots, and then you can flash the code to your microbit. Okay, why do we call it flash? Highlight juga kan? So the program that we uploaded to the microbit, do you notice every time when you uploaded that it disappeared? Actually, it's uploaded to the flash memory. Okay, so we call it flashing. Okay, so when we upload done already, right? The light also will be stop blinking. Okay, right. Okay, I forgot to put one more thing. We need a strip show. Okay. Show is something like kalau ada dalam Arduino kan dia ialah high. Okay, if you do not put the high, then it will not turn on. Okay, so you need to put show. Okay, so now you can see when I turn it on, this is the switch, I turn it on, so it will start to run the code. Alright, then the light will slowly every 1 second turn on 1 LED with the color red, and at the end of it, turn it off. Okay. Okay, so that is the NeoPixel. How about I want to do something with a rainbow color? Okay, rainbow color, we can also use okay, let's try. So 1 second, red. If I'm going too fast, you also let me know, because I tend to go too fast. You can use the keyboard shortcut, Control C to copy, Control V to paste. Okay, so that's complete the rainbow color. Let's try to run the code. Okay, so so the picture managed done. Okay, so that is the rainbow color. Okay, now how about we do running light effect? Okay, we can use the rotate pixel. Create foreverse. Okay, we try to put 1 second so that we can see the difference. All right, so you can see here. Every 1 second, rotate pixel, right? You see the red color, it will move in 1 pixel at a time. Okay, go back here once. Okay, yeah, so it will keep on rotating, all right? Okay, so we can make it faster by reducing the time, the delay. Okay, change to 200. 200 ms equivalent to 0.2 seconds. Okay, so every 0.2 seconds, it will move 1 pixel. Okay, so you can see it's faster now. All right, all good? Okay, so that is lesson 1. So here we can use publish to share our project. All right, so you can ask the student to submit their assignments by using this share. Okay, so I will just share this project with you all. Okay, so that concludes our new picture, which is the chapter. Should be chapter 2, I think. Oh, I hear someone comment. Ada apa-apa soalan? Yeah, any question for the lesson 1? Oh, it's the new picture actually is lesson 2 lah. But lesson 1 should be no problem, right? The source string, the source numbers, it should be quite straightforward. All right. So that is the flow chart lah. The on start, okay, then you show strings, okay, then this is the forever. Okay. So any question on the neo pixel? So far so good. All right. Okay, so here is doing the traffic light challenge. You can also ask the student to do something like this, okay, for the traffic light challenge. Okay, so basically what we can do is we just need to, all this 0, 1, 2 change to red color. Okay, this one we don't need. Okay, and then all this is blue. So the time delay, we can just do it away. Okay. Let me put 200. Okay, so we will need the bread here. Okay, so that will be a polysilent, the simple one. Alright. Okay, so far okay, right? Very easy, very straightforward, right? Okay. Now I'll move fast a bit. So that is the traffic light challenge. Okay, so this is a melody. Birthday song. Okay, we can do a birthday song. Yeah, we can try to do this. Okay. Okay, we can get the button A, and then we go to get middle G. How do we get the middle G? Okay, we can go back to microbeat, and then let's do lesson on. Okay, or you can actually refer to the bullet. We do something more fun now. Let's try the baby shark maybe. Okay, so this one we can also use this to learn melody. Okay, so melody, like there is some notes here for you to learn. Okay, this is a happy birthday songs. Okay, how do you read the notes? Okay, here are the lesson plan here, and then let's try to do the baby shark. Okay, you can download the bullets and then refer to page 44. Okay, then we can try to do this baby shark. Okay, so for those of you, you can go to the bullet, download the bullets. Okay, or you can just look here. This one actually is lesson 3 lah. Lesson 2 later. Very sharp. Okay, we can actually save our file by customize our file name. Okay, and then we can save it to our desktop. Because everything that you save to your microbit, you won't be able to retrieve it. So if you want to, if you like very sayang your hot gun, then you just download to your local drive lah. Okay. Okay, let's go to the music. So we will need to set the tempo kan, because tempo dia adalah 115 pas, bit fast. So the tempo here by default is 120 bit per minute. Maksudnya every satu saat adalah 2 bits. Okay, so how do you set the tempo? Can change 1 1. Hi. And then can get the input. Okay. Yeah. Wow. A lot there. Okay. Okay. Let me put. Okay, no problem. So sorry, yeah. Because my TV is big, so I thought you can see also. All right, so let me try again. Okay, let's go find the ID for 1 bit. Okay, that actually is a frequency. The higher it is, the higher pitch it will be. Then IE will be 1 bit also. Okay, so now we can also use function. Forgot. Okay, functions. What is function? Okay. We can actually use functions to do the chorus. Okay, the chorus. So from here you can see these are actually the chorus. Okay. Sharp do. So we can do the chorus first. Go to the function, is under advanced here, function. Then you can name your functions any name that you like. Okay. In this case, is chorus lah, chorus ya lah. Ataupun boleh namakan dia. Okay, and I do not need to repeat this many times. So under function, I just call this one. And meantime, the line 2 and 3 is repeat. So I just use the repeat 2 times for the line 2 and 3. So when we press the button A, okay, so that is the daily sharp. Okay, so let's try to download it to your Rero Micro. I already paired this. Let me just alright. Bit funny later song. So, this one should be high D. Wrong key to that. Okay. Okay, so we actually can use this to do some with the disco light effect, what I call it. Alright, so we can do something with the NeoPixel also. Right? Okay, so I will need the NeoPixel extensions. So every time it changes speed, I want it to change color. So, okay, we can go to the NeoPixel extension and then just click show color. So you can see when I click show color here, put it here, right? There will be an exclamation mark. So the reason for that exclamation mark appear is because I belum define apa itu strip. So we can go to the NeoPixel and kita bagi tahu micro:bit. Strip itu adalah pin 1 and pin 1 ada 7 LED. Okay, and then the exclamation mark will disappear. All right. Okay. Okay, then you can see from the simulation. Okay, that's good. Okay, then if you want to see in actions, just download it to your micro:bit or rero micro. Okay. So I press the button A. Okay, we can add movement to it after we've done the chapter 3. Okay. Okay, so far okay. Chapter 10, kami tak pernah berjaya buat. Oh, chapter 10 itu apa? Sabar cikgu, nanti kita akan cuba buat. So, now, let's come back to the DC motor or actuator, alright? So this is actually using differential drive system. Okay, so there are the dual motor, right? So it's left and right motor, right? Left and right motor. So basically, we will always encounter a problem with DC motor is they are tidak synchronized, okay? So because there are the differential drive system, is two different DC motor. Even though the motor is manufactured by the same factory, okay, chances are they might not be able to synchronize. All right. Reasons being maybe they are not voltage recently difference. Also, it will be coming. The battery will be coming. The voltage will be getting lesser over time, right? So the same program that you use, it might affect the result also, right? So here, let's go to lesson 3. About the trader. Okay, a very simple test we can do is, by the way, lesson 2, okay, right, everyone? Oh, good, huh? The baby shark and everything. Cannot hear. Okay, so no question means okay. Right, so we will need an extension, micro extensions. If someone is asking question, okay. If no question, then I move on. Okay, so we just get a rero micro. Okay, we can test our robots on button A press. Then we go to move forward. And then we set a time to see the robot whether it's moving on the straight line or not. You get 1 second. Then you just get the robot to brake. Okay, then you can test the robot. Kalau your robot is moving slightly to the left, means your left motor is moving faster than the right motor, right? Even though you program it moving at a speed of 50. Alright, so how do you calibrate? Kita boleh pakai functions untuk calibration. Okay, so hardware limitations, software boleh menangani hardware punya limitation lah. Alright, so we can do like forward. then we can program the robots run left motor and right motor. Okay, so just now it's the left motor moving faster, right? What we need to do is just maybe try to put it 49 and see how it goes, right? So ini adalah cara untuk software calibrate your motor. Kalau dia tidak dapat move in a straight line. Okay, all good? Another solution is simple saja. Make sure your battery level is not affected. Okay, or you just simply change this DC motor lah. Because this is a wire. Okay, we can easily swap it. Okay, if you want to change a new one. But not necessary lah. Okay, I will not recommend that one. Unless it's really cannot move lah, then you only need to change it. Okay, so all good? Okay, so now let's try this one. Okay. Okay, so basically this one is for us to do design movement. Okay, so we can try to program the robots to maybe do something like, okay, let's try this. Delay, we put speed 50, turn left, speed 50. Delay, we put 500. Let's try this. Okay, and then we download to our Keluarga. This is another robot. Okay, I'll just download this one. Okay, followed by this one. Turn left 50, and then we can see on okay. So you can see from here, you press button A. So the anchor is 500, not 50. So if I put 50, the angle is about almost reaching 20 degree, but not until maybe 50 degree. So now I change to 500. Okay, I download again. So it's 180 degrees now. Because why? Because I changed the delay to longer period. The duration is longer. Okay, so if you want it to be more precise, we can reduce the speed. Okay, and the delay we can put longer time. Because if you want like high accuracies means you need to lower down the speed lah. Just like if you drive fast, you cornering, then your corner will not be, you might be drift away, right? Same thing. All right. So there is the software calibrations and precise movements. Okay, this one is activity sheets that they can do lah. So every motor, like since I already mentioned just now, walaupun pengeluar, I mean like they are manufactured by the same factory, doesn't mean that the both motors are in synchronized. All right. So we can use software to calibrate. Okay. So far, any questions? Oh, good. Very good. All right. So we can actually program a robot to draw triangles or squares by using this one. All right. For example, I always like to ask my student to do something like square. So if you want to draw the square, it means you need to do some research lah, trial and errors to find out how long we need to do for the maybe 90 degrees. Okay, we can do, for example, just now 500 for the speed of 50 is about 180 degrees. So I can try maybe 30, 300. I'm not too sure, but I can try. Okay. This is different robots. Okay, so it's about 60. Okay, now I try a different one. Okay, maybe I put 500. Okay, this one I use another robot. The first trial one. Download. Okay, to know that our code is downloaded or not, we can do one trick here, which is you can put a show icon left, for example. So when I download the code, when I see the show icon left, then I know that my code is successfully downloaded. It's taking longer than usual. Okay, right. Just try again. Okay, try. Okay, I just go as file. Okay. So as you can see, there is a love icon here. And I know that is possibly over there. Alright, almost 90. Alright. Okay, maybe 400 will do. Okay, so the precise movement is quite an important trial and error that students they need to masters, so that they can do like draw their names or draw triangles or draw equal length squares. Okay, and they can also use functions to do that if they have some hardware limitations like what I mentioned just now. Okay, then I'll just show you further. Am I moving too fast? Okay, so now you can see that is 90. Right, so this is for 90 degree. Okay. Right, about 90 degree. Okay, so if you want to do like drawing a square, I'll just put 450. Okay, so you can put like 1, okay. Is it correct or not? Okay, move forward, then turn left, then move forward. It should be okay. Yes, so it's correct. See how square it will be. Okay, another thing is about frictions. So the first surface of the tables or your floor will also affect the robots. Huh? Okay, so that is a square. Can you see? Alright, okay. So that is the square. So Okay. How about triangles? Triangle, I will let you to figure out because triangles you will need 60 degree, right? So that one you can let the students to try. All right. Okay. So a lot of activities that we can use on these robots. Okay, you can actually use it to draw because it comes with a hand holder. So you can basically ask the students to draw their names or draw a shape. Yeah. So it came with gel pens inside the kits. Okay, so this is the gel pen that is come with it. Okay, let's just put on it. Yeah. Okay, then you can program the robot to draw a square. Or if you want a marker, then you can use this one. Okay, using the RI marker pens. Okay. And okay. Yeah. Okay. So that is chapters. This is chapter 4 challenge. Okay, program your robot to do a. You just draw a square lah, easier. Okay, just now I already showed you how to do it. But if you want to challenge yourself to draw triangles, feel free to do it. Okay. Now obstacle detection or correlations detections. So here microbit comes with an accelerometer. Apa itu accelerometer? Accelerometer is in the okay. So you can flip over the microbit. Okay, you can see here. Okay, yeah. So here actually is a accelerometer. So what is the accelerometer functions? It actually can detect X, Y, and Z. So the Z is the third dimensions. Okay, so X, Y is left or right lah. Okay, so we can actually use the microbits to do the correlation detections. Okay. Okay, so we can use the accelerations. Then by here we will need the axis Y line examples. So we set the axis Y to accelerations. Okay, so the axis Y, the variable pemboreh ubah axis Y akan menjadi accelerations. Okay, bila acceleration dia detect berapa, dia akan forever dia akan go back to the axis Y. Okay, so after that, okay, you can repeat 10 times. Why we need to repeat 10 times? Because sometimes the first reading or the second reading might not be so accurate. The value might be fluctuated. So that's why we need to repeat 10 times, and we divided it by 10 times. We get the nilai purata, okay, so that it can be more accurate. And we get accelerations. So with the multiply it by 10 times, and then we get the if L logic comparisons. So a bit about physics here. Okay, so the G, like correlations, like normally our car have the accelerometer to detect correlations. We are using the G. So when it hits something, right, the G will be fluctuated. So the accelerometer sensor, when it exceeds that value, it means the impact is too great for us. Is so that the airbag in our car, right, it will trigger. Okay. So for rero micro, right, depending on the surface, sometimes if your floor is not that flat, not like our table, right, the value maybe it can be you need to put higher a bit, okay? So basically this one you have to trial and error lah, okay? So this one we can use the axis Y. If the axis Y is like less than 100, then what it will do, it will trigger the airbag. Or for this one maybe we can do some, I think they have an exercise here. Okay, so it will reverse slightly, turn right, okay, 90 degrees, and then continue to move forwards. Okay, so just now we have done 90 degrees, right? So we just move backward a bit. -90 degrees. Then do what? Continue to move forward. Okay, so this one is to move forward. Okay, so this is the correction detection. It is by using accelerometer. Okay, okay, maybe I'm not sure I have enough time, but you can actually go to this the hard way. Somewhere I think it's here. Okay, hard way here. So here you can actually go to search for the video explanation on accelerometer. That one you can also learn. Okay. So far, any question for the correction detection? You can try it on your robots. If you have a robot, then you can try it. Okay, good. Obstacle detections. Okay, so XY actually has not much difference because the microbit is too small. Huh? Yes. Okay, so X is move like left and right lah. So Y actually is backward and forward and backward. Okay, so another axis is Z. Z is like free fall. Okay, maybe I change. Actually, very hard to tell the difference by using microbit sensor because it's not that accurate. So this is Y. Okay, this is X. This is Z. Okay. All right. Okay. So now we go to the obstacle detections. So this is how we use the if else also. We set conditions. Let's go to obstacle detections. Okay, we can put here. Okay, so we will need rero micro extensions. Okay, we can do something like if obstacle detected at 10 cm. and it will brake. Else, it will just move forward. Or we set another, give another condition. 20 maybe. 30. This one. Okay, you can try this on your robots. So if you want to use less than comparisons, the smallest number always at the top. Okay, so you can try it on your robots. Yeah, I think I need to switch on my other cameras. Okay. So this one is like obstacle. So the object of your obstacle, it has to be greater than the robot's line. So you can see that it will, when it almost reaching the object, okay, it will slow down, right? And then ultimately it will brake when there is 10 cm gap in between. Okay? So that is actually obstacle detection, so easy. So once you set the condition correctly, it should be able to work. Okay. Okay, apa itu ultrasonic? This one, how it works. So we can also use this as a lesson untuk mengajar ultrasonic sensors. Okay, how the bat is using the ultrasonic sensor, the wavelengths to detect their prey, okay, and hunt for their prey, and how it can be more accurate than infrared sensors, and also the limitations there. Okay, so if object is too far away, or object is too small, objek yang macam kain memang tidak dapat lah. Okay, ataupun the angle dia, angle juga akan affect lah. Okay. So this one I see. Okay, it's a bit long time. Now we play with light and shadows. Okay, so dalam rero micro dia juga ada light sensors. So we just replace this one with our light sensors, which is the light levels. Okay. Okay, so this one, if light level is more than 50, then it will turn left, else it will move forward. Less than 50. So we can catch the shadow on the robot, then it will turn left. But before that, we also need to get the threshold value first lah, because all the ambient light is different, and then we can use, let's say for example, potential numbers. Then we can get the light levels. So when you press button A, then it will show your current. The first number will becoming 255 because it detects the LED light. Okay, so you need to get like the second reading. Okay. Okay, so now what I see here is like 42. Okay, it's like 33. Okay, the light level now is like 33. So maybe I can put $33. Right. It's moving fast. Okay, and it's going to be too fast. Yeah. Okay. Okay, so that's how you do with the EPL logic and the light level. And how do you find the threshold value on the light level by using draw number. Okay, same thing also ultrasonic, you can also use this. Okay, by using ultrasonic, you can also detect distance, measure distance. Okay. All right. So far, any questions? I'm not moving too fast, right? Now let's go to the, what is this? Oh yeah. Okay, yeah, we can play this game. By cast the shadow and then turn left. Yeah. Okay, it's quite fun. Okay. Now follow the line. Okay, we can use the 3 array of the light infrared sensors, okay, to follow line. Okay, so the red line sensors. So you have to be in reverse. So when the center sensor is detecting line, then you the robot to move forwards. And if the left sensor is detect line, then you ask the robot to turn to avoid the okay, let me see this one. Okay. To avoid the left, when the left sensor detect line, to avoid the red line, we need to turn left. To turn left, right, your right motor have been moved faster than the left motor. Okay. So your right motor, it has to be moved faster. Right. And for the right detect line, you want to avoid the brake line, you need to left motor move faster than the right motor. Giải từ ballet lah. Okay. And L is just correct. This is the line detection. Okay, let me just unlock. Okay. Still not yet uploaded because it's showing icon love. I don't think it's uploaded. Okay. Let's see. Let's download this file. Okay, so you see or not? Okay, turn it on. Okay, so now it will follow line. Okay, so this is the thought for the line following, and the theory behind is when the left sensor is detecting line, the red line, it want to avoid the line, so it turn left. And then when the center sensor detect line, it moving forward. And then for the right sensor, it just need to avoid the line, so it turn right. Okay, so it will always keep following the red line by avoiding the red line on left right sensor. Okay, so far okay. Okay, so we can actually use the obstacle detections. For example, this one, let's put it there. Okay, if obstacle detection is less than 10, tell the robot to brake. Okay, so this one, when it detects obstacle, it will break. Okay, so this one we call it nested if. Okay, nested if. Inside the if else, got another if else. Alright, then we can try. Yeah. Okay. Any questions? May I know how do we calibrate? Oh, no need calibrate. This one's a nudge. Sebab all this is auto calibrations. Unlike you want to learn on calibrations, get the truth bit. This one you will need the calibrations. Jumbi will need calibration because it's using mechanized. If you got Jumbi, I will teach you how to do the line calibrations. Okay, any other questions? Just make sure your room is not too dark because it's using infrared. Okay, and then one more thing is the black light cannot be reflective light. Because if reflective, it will also detect as white. Okay, so the surface cannot be reflective. So if you want to print on like banner, right, you need to print it on the metal material. Okay. Okay. Any other questions? All good. All good. Then I move on. Okay. Let's see. Count junctions. Okay. So count junction basically means we add another conditions, which is junctions. So in under what conditions you will count junctions? And junctions. Which is we need a Boolean logic, and when 3 signs is detect line, means it can detect the junctions. Okay, so if you want to use variables, remember to define your variables at start. So we define the junction value 0. Then every time when it detects the junction, we change junction by 1. Maksud dia akan tambah 1 lah. Okay. Then how do you show the numbers? We get the basic broad show numbers. Okay, like what we did with the ultrasonic sensor and light levels, we put the variable junction here. Okay, simple as that. Okay, now you can try by download. Okay. Okay, so just put it here. Turn on. One. Okay, so here it stop. Okay, because when all sensor doesn't detect light, we did not set a condition. What it should do? So that's why we need to do another condition. Inverted logic, not what should it do? Maybe we just ask the robot to turn a little bit left because it's too right, then it doesn't do light detection at all, right? So all this is all about logic logic thinking, okay? Computational thinking skill. Okay, so okay, let's try the new form. Okay, now we can try on the new code. Okay, so it go back to following night when there are no so I have another problem. So now what should we do? That's why we need to problem solving. So maybe that is not really a good idea at all. Okay, well, what should I do then? Maybe I just look at the pieces. Okay, maybe I better put the turn left here when it hit that junction. That should be a better idea then. Yeah, why don't we try that? So this is a thinking process lah. Okay, so we don't say, oh, your code is wrong or what, but we let the student to try, and in the process they will learn something. Okay, let's try this one then. And we need to move forward a bit, right? Let's try move forward a bit. Okay. Okay, that should be fine. One. Okay, let's try the new one. hope it works. Oh, two right, two left already. Means I need to reduce. Okay. Don't give up. Keep trying. Okay, now finger cross. Okay, let me see which. Okay, this looks good. Let's go around. Okay, looks good. Now it's better. Okay, so now another program come up. So sometimes we need to try to figure out what are the better way. So maybe this one I don't need. Okay, so we can always try. Okay. Or maybe I need to move forward a bit first and turn left. Instead of turn left and move forward. And the speed I can reduce to 30. Yeah. So that it can cross over the obstacles. I mean, not obstacles, the junctions. So it's okay that you take a few times to try and errors, because from there, then they understand. They need to see why the robot doesn't turn as intended, or maybe because the sensor detected is too left or too right. You need to add on another few blocks and manipulate the delays or the speed so that your robots can be more, the successful rate, the accuracy will be higher. Track 2, sepatunya kena betul-betul bak rata. Yes, yes. That will be one of the factors also. Okay. This one also another factor. Okay, we need to solo tap because I did not solo tap the thread, right? So that is not too flat. And then the thread will keep on moving. Okay? When there's a movement involved, the thread will move as well. Now it's become better. Right. Thank you, Cikgu, for pointing out the obvious. This is very, very good now. Okay, sometimes we just need to find out why it doesn't do. Maybe it's because of the shadow, maybe it's because of the condition, the light detected, the mat 230 a lot of factor lah. Okay, now how do we do escape the ring? Okay, escape the ring, we need to set the. Do we have time or not? Okay, we should have enough time. Okay, we just need to set this one. Okay, we use the function follow y. Okay, to follow y. We simply let's see. Okay. Yeah, right. Okay. So we just do the move forwards. Maybe not too fast. And this one we just chain left, chain right. Okay. So this is the follow y. Then follow back. Follow back is like as usual with the next one. Okay, so when we detect the line, we can ask the robot to reverse or turn left. So now if turn right, instead of turn left, we turn right. So then we go to the white area. Right, and then the degree, how many degree? Okay, I'll go to the how long? Just go back. Okay, then we get another variables. Okay, use junctions. Okay. Maybe I just after junction 1, then it's junction 1. So it's 0. Okay, define what is junction. It's follow back. To start with. Okay, so turn right, move forward. We should go to the white area. Then after the white area, if no line detect any line, it will move forward. So this one, if less sensor detect line, instead of turn left, it will turn right. Okay. Okay, maybe I just put this one. Obvious. Okay. Follow the speed. Okay. Left, center, right. So this is white, so I just need to reverse. When the white is detect line, it means it detect the junction already. So move forward, and move backward, and then turn right, 90 degree. Then forward. You have to try on your robot because like what we already said, all the DC model will be different. Okay, the RPM is different, rotation per minute is different. So okay, so even my code is work on my robots doesn't mean that your code and your robots works the same. Okay, so you need to always fine tune and find out your best calibrations. All right. So now, why this one for exclamation marks? That is not right. Oh, there is a loops. Yeah, right. Okay. Now let's try. Do we have times? We have 3 minutes. So if I fail, don't blame me. I just simply need more times to calibrate my robots. Okay, but anyway, the theory, the concept is there, right? So far, any questions? Let's see. Oh, I need to put one more thing move forwards. Okay. So all this is like logical thinking. So once you get the concepts right, then it should be no problem. Not too fast. Sometimes if too fast, it will abstract. Okay, I need to download the new cards. fire, straight away go to because it detect that one. So it's straight away. Okay, I will do it one more time. Okay. Được rồi lệ. This is left. Open chance. This is right. Okay. So this is again the chapter 10 challenge. Okay. Alright, so let's conclude our workshop for today. I cover as much as I can. So far, any questions? Sorry if I'm moving too fast, but yeah, if you have a question, more than welcome to ask. So far, okay? So I think we are at the end of our workshop. Okay. Right, thanks for joining me. But ask oh, you're most welcome. How to screenshot? Let me try. Okay, hold on. I think I need to. Oh, okay. Okay.